While we're on the topic of VLANs and trunks, I want to tell you about a special type of VLAN. It's a voice VLAN. Let's imagine that we have a situation like we have depicted here on screen. Maybe we're rolling out IP telephony within a company. We're replacing the traditional PBX phones with IP phones. These IP phones, they are Ethernet devices. They plug into that RJ45 connector in the wall, but what if a particular office or a cubicle only had one Ethernet connection to start with? And we had a PC or we had a laptop plugged into that connection, and now suddenly we're adding a phone. Does that mean we have to put a switch in this office to accommodate another Ethernet port? Do I have to put another Cat6 drop in this office? Well, the great news is many of our Cisco IP phones have a port on the back labeled PC port, and it allows us to sort of daisy chain the PC into the phone and then go into the wall. The phone itself is acting as a little switch. It's technically a 3-port switch. One port goes to the wall jack, one port goes to the internal workings of the phone itself, and this other port can connect to this PC. We don't have to run additional cabling, or we don't have to add another switch into that office. The phone will handle that for us. And notice what's happening here. The PC that's attached to the phone gets to be in a different VLAN. Here I'm saying that the laptop is in VLAN 300, a data VLAN, and the phone is in VLAN 400, a voice VLAN. And that's going to give us some benefits. It's going to give us performance benefits for one thing by having VLAN separation. If we had a big broadcast storm on the data VLAN, that's not going to negatively impact the voice VLAN. And it can also help out from a security perspective, where somebody is not going to be able to attach a network sniffer to the network and start sniffing voice packets. That's the idea behind a voice VLAN. We have a separate address space, a separate broadcast domain, a separate subnet for voice traffic. And there are different ways that we can set this up. This port into which the phone is connecting into the switch, it could be a single VLAN access port, in which case the PC and the phone would be a member of the same VLAN, and that's the least desirable of these options, by the way. Another option is it could be connecting into a special type of access port, a multi-VLAN access port, or it could connect into a trunk port. We know that a trunk can carry traffic for multiple VLANs. Well, that trunk between the phone and the switch could carry traffic for the voice VLAN and the data VLAN. Let's take a look at these one at a time, beginning with the single VLAN access port. With a single VLAN access port, that port into which the phone is connecting, it is an access port. And like most access ports are, it is configured for only one VLAN, meaning that the phone and the PC are members of the same VLAN. It doesn't seem like this is giving us much of a benefit, does it? When would we use such a thing? Well, maybe we're using a non-Cisco IP phone that doesn't support the concept of a voice VLAN, or maybe we have a software-based client on our laptop, on our PC. Maybe it's a Jabber client, maybe it's a Cisco IP communicator, but if it's the same device that's acting as the data device and the voice device, then we might need to use a single VLAN access port. However, even though we're doing that, we still can get some quality of service benefit from this configuration. Remember when we were talking about an 802.1q trunk, we mentioned that except for the native VLAN, the other VLANs had 4 bytes added to their frames. And inside of those 4 bytes, we had 3 bits called the priority bits. And those 3 bits could be used to indicate the priority of a frame. And with 3 bits to work with, that gave us 8 possible values of priority, because 2 raised to the power of 3 is 8. But Cisco says, do not use values of 6 or 7. Those are reserved for network use. We could only use values for production traffic in the range of 0 through 5. And that's the value to which voice frames should be set. They should have a marking, a COS, a class of service marking of a 5 on a .1q trunk. And the great news is, Cisco IP phones do that for us by default. And if we enable .1p on our switch, even though we have a single VLAN, it can still accept frames that come in that have 4 extra bytes. Now this is not a trunk, but if we enable the port for .1p, it will accept a frame that looks similar to a trunk frame, and I say similar because it's still going to have 4 extra bytes added. And inside of those 4 bytes, there are 3 bits that are going to be used to mark the priority marking. But we call this a .1p marking. What's the difference between a .1p marking and a regular COS marking that we would have on a .1q trunk? Well, a .1q trunk uses 12 bits in those 4 bytes to indicate a VLAN ID. .1p does not do that. .1p is not tagging a frame as belonging to a particular VLAN. In fact, if you were to look at those bits representing the VLAN field, they would all be set to a 0. That's the big difference between a .1p marking and a COS marking, which is part of a .1q trunk. And we'll see in a few moments how to configure that switch port to accept .1p markings. Another option we have is to configure this switch port as a multi-VLAN access port. That seems like an oxymoron, doesn't it? How can you have multiple VLANs on an access port? Don't we have to have a trunk port in order to support multiple VLANs? Well, Cisco gives us an exception here. Cisco says, okay, you can have a couple of VLANs appearing on an access port, if and only if you say that one of those VLANs is a voice VLAN. What a great solution. This way, I can go to this port and plug in a laptop, and it's going to work just fine, just like it's an access port, because it is an access port. But if I have a phone plugged in, and maybe I've got a PC plugged into that phone, the phone will automatically learn that it belongs to the voice VLAN, while the PC is going to belong to the data VLAN. How does this work? Well, like we said, this truly is an access port. We set the switch port mode to access, however, it can support 2 VLANs. If we say one of those VLANs is an access VLAN or the data VLAN, and the other VLAN is our voice VLAN. The way the phone learns which VLAN is the voice VLAN is thanks to CDP, Cisco Discovery Protocol. The switch is going to send a CDP message, and by the way, it has to be CDP version 2. This does not work with CDP version 1, but the switch is going to send a CDP version 2 message to the phone to say, here's your voice VLAN. And now, when the phone sends out a DHCP request to get its IP address and its subnet mask and its default gateway and the IP address of a TFTP server that it needs, when it does that, it's now going to be able to do that as a member of the appropriate VLAN. It's going to be asking for an IP address belonging to, in this case, VLAN 400. There is one caveat I need you to know about, though. Remember we talked earlier about CDP, the Cisco Discovery Protocol, versus LLDP, the Link Layer Discovery Protocol? Well, this approach of having a multi-VLAN access port, this does not work with LLDP MED. Link Layer Discovery Protocol Media Endpoint Discovery is what that stands for. If we're relying on LLDP instead of CDP, and you can only run one or the other on your switch, then the phone is not going to be able to automatically learn its VLAN assignment if we're trying to do a multi-VLAN access port. If we have a situation like that, we're using LLDP MED, we should probably make that port a trunk port, and we'll talk about that in just a moment. But if we are using CDP, this is a great way to go. And if you were to do a packet capture on a frame flowing between that phone and that switch, it would look like a .1q trunk frame. In fact, if I were to give you a packet capture and say, can you tell me, is this frame going into a multi-VLAN access port or is it going into a trunk port? You would not be able to tell me the difference because it is identical to a trunk frame that we would find on a .1q trunk. Specifically, frames coming from the phone are going to be tagged. They are going to have those 4 extra bytes. And those 4 extra bytes do contain a VLAN tag, in this case for VLAN 400. We are going to have 3 bits in those bytes that are going to mark the COS, the class of service priority marking for the phone's traffic, and the phone automatically sets those to a COS of 5. And remember, on a .1q trunk, we have one VLAN that we say is an untagged VLAN. Well, the data VLAN in this case is going to be an untagged VLAN. The PC's frames going into the switch, they do not have those extra 4 bytes. Those are 2 options for connecting an IP phone to our Cisco Catalyst switch. Let's take a look at another option. And that other option is to use a trunk port. In this case, the port is a trunk port. It's going to be a .1q trunk port. And we know that a trunk can carry traffic for multiple VLANs. And if we are using LLDP MED, or if we're using CDP, this is going to be compatible because we're not using that special exception that Cisco gives us for a multi-VLAN access port. And the frames truly are .1q trunk frames. They look identical to the frames that we saw with a multi-VLAN access port, but here we do technically have a trunk. The switch port itself is configured in trunk mode. But that in itself brings up a bit of a challenge. Because think about it for a moment. By default, traffic for what VLANs flow over a trunk? And the answer is all of our VLANs. That means that depending on how you have your phone set up, you could have, in some cases, depending on your phone model, depending on your configuration, but in some cases you could have the attached PC, the attached laptop, run some sort of a packet capture utility and capture traffic, not just for the data VLAN, but for all of the VLANs appearing on that trunk. You could see unknown unicast frames, broadcast, multicast frames. From a security perspective, that's not good. Therefore, Cisco strongly advises us to prune off any unneeded VLANs from that trunk. Those are the three options for connecting an IP phone into a switch when we might want to daisy chain a PC into that phone. Again, we had a single VLAN access port where the phone and the PC shared the same VLAN. We could still get some quality of service enhancement thanks to .1p markings. We also had the multi-VLAN access port. That's where Cisco does a bit of a paradigm shift and lets us have an access port that carries traffic for two VLANs, if and only if one of those VLANs is declared to be a voice VLAN. And that's a great solution, unless you're running LLDP Med instead of CDP. In that case, it's not going to work for you. In that case, you would need to use a trunk port. And maybe you have an older Cisco Catalyst switch that doesn't support the concept of a multi-VLAN access ports. That would be another time you might need to use a trunk port. And if you do use a trunk port, it's going to work great, except you're going to have extra traffic coming into that phone that could be potentially sniffed by the PC, and you don't want that. From a security perspective, from a performance perspective, you don't want unneeded packets coming into your phone. And the recommendation is, let's go in and prune off any unneeded VLANs from flowing over that trunk. That's a look at the theory of voice VLANs. In our next video, we want to see how to configure voice VLANs.